share the project details, students. Please get back to your Telegram group. Check the pinned messages. There we have sent you the full length recordings of each sessions, except AMA session. Because this AMA session is a live session, we would want students to participate in that directly. Okay, so where all your questions will get answered. You will also get a chance to speak to us, right? Where you can ask your direct questions to us, you will get answered as well. But please ensure that you are joining the live session. AMA session recording we won't provide. So please ensure that every Friday you are not missing this AMA session. Yes, attendance for AMA session is also compulsory. It's mandatory. Just like any other sessions, attendance for AMA session is also mandatory. Our link is also there in the group. So regarding the project works, already we have given you the framework, right? So you have to do a project either on artificial intelligence and machine learning, because that those are the topics we are getting covered in this internship, no? So choice of the project title is, is yours, but infuse artificial intelligence and machine learning in that. And you have to prepare a PPT on a specific topic with all the inputs. The project template, the trainers will send you in the group. You don't have to worry about that. Ma'am, how I have to submit it and all that. That particular template will answer all your questions. But you need to have some good idea in your hand so that the best projects, will be taken to Microsoft. Right? So, yes. If your project would like to get recognized or to present in front of Microsoft team, so please ensure that you choose a unique topic which is currently in trend. We are seeing a lot of things around AI, machine learning and all that. Do not rely on ChatGPT kind of thing, but, take all the learnings from the sessions, refer other videos, right? Imply your learning on that and create a very nice, engaging project and submit it to us, and we will evaluate that. And just like that, course completion is also important. Completing all the courses from the LMS advanced section is compulsory, right? So please ensure that you are logging into your LMS properly. Complete all the courses under advanced is compulsory. Do that and mark your everyday attendance properly. Okay. Bittu Kumar, why am I not unable to find the mic option? Okay. See, Bittu, if you were there in the AMA session, we have given you the mic access. In fact, we were just waiting for the last 15 minutes without being asked with any questions. Right? In that case, definitely, it's clear that you didn't attend the session. In AMA session, if you raise your hands, then definitely we'll allow you to speak. That is how it works. No issues. Even if you missed last week's AMA, this week also we have our AMA too. You can attend that. All the courses are just A fluency. Not just A fluency, all the 6 courses under advanced is compulsory. All 6 courses. If you have attended the AMA session, I have clearly shown explaining the LMS. Recommended courses, then advanced. Under advanced, there are 6 courses. Complete all those 6 courses, not just AI fluency. Please remember that. What's your request, ma'am? Can you show an example of project? See, the trainers will give you the inputs. The sample inputs will definitely be discussed in the session, but it's you who have to take the input and implement it. Bittu, I have told you, like next time you can, join the session on time. AMA session is just for 30 minutes only. Join the session where I'll make you to speak. But you have to raise your hand. Mic option cannot be given to everybody. Otherwise, it will be very clumsy. Only the selective students who have queries will raise their hand, and after that, we'll make them to speak. That too only on AMA sessions, not on regular sessions. So you can put down your hands now. We're still waiting for more students. Let's wait for 2 more minutes. Okay, one student, Vishwanath, is saying that, ma'am, some courses are redirecting to Microsoft Azure resources are provided in the AI advanced courses. Okay, but subscriptions are required to access the course. See, subscriptions will be there, but it is completely your choice to take that or not, right? Because all the practical things have been discussed in the session itself. So if you are unable to proceed, not like unable to, it's your choice whether you're going with that or not. But for one or two courses, there must be a subscription requirement to access hands-on exercises. But it is not, compulsory. It's your choice. You can just click on proceed and proceed that. That is it. It's your choice. It's not compulsory. Right. Any other sessions will trainers, in all the sessions, the trainers will discuss about your project works. Step by step, they'll discuss it for sure. Some of the students, they just copy the content from ChatGPT and put it here. It won't work. Please be very specific in, whatever topic that you choose. It's your choice. Again, I'm saying it's your choice, but make it the best. Okay. Some students are asking, even you have raised this in the LMS also, but please understand, your certificate will be issued within 5 working days after we review your submissions. See, this is for your internship completion certificate, not for the courses like advanced, basic, not for those courses. We'll be giving you only one certificate, that is your internship completion certificate. So please ensure that you're not asking for the certificates now. It has its own time. 15th of July. That means after the second week of July only, your project deadline is approaching, right? And after that, we have to validate your projects. And after that only, you will get your internship certificates. That too only for the eligible students who have completed all the eligibility criteria. You will get your certificate. That too after 15th of July, after your deadline. Your trainers will share more information about projects in today's session. No worries. Yes, your certificates are from MS Learn, right? Certificates as in, there is no certificates. Okay, you will see an achievement page. And you have the option to share it in your LinkedIn as well. If you do not want to share it on your LinkedIn, then you can take a screenshot of it and have it as your achievement. So for Microsoft, for MS Learn specifically, there is nothing like certificates. It's only the achievement. Okay, number one. Number two, if you're asking about the internship completion certificate, that certificate will come with the Microsoft logo and this thing. Okay, other logos. But for MS Learn, it is only achievement. Okay, no certificates. Just ensure that you're not raising the same question on LMS again. There will be only one certificate, that is your internship completion certificate. In case if your college is asking for any proofs of this internship, you can submit those achievements as a proof. Okay, to show that you are already enrolled into the program and you are taking the courses as well. Show the proofs from LMS and all that can be used. Okay. Sahitya is asking like what days will we be having the EduNet meetings be conducted in a week? See, Sahitya, I hope you have your schedule screenshot with you, right? So if not, go to your Telegram group, check for the orientation PDF. Okay, there we have the schedule details. Okay, to keep it very precise, Tuesday and Thursday. Okay, Tuesday and Thursday we have technical sessions, and Friday we have AMA session. So weekly thrice you'll have to attend the session. So technical sessions usually it'll be in a span of 2 hours from 5 p.m. to 7 p.m. And for AMA session, it is for 30 minutes. Maximum we can, just extend it for 15 minutes. So MA sessions can be from 30 to 45 minutes, not more than that. Every Tuesday and Thursday, technical sessions with your technical, trainers here. And every Friday, we have AMA session. That too for only for this 4 weeks, not more than that. Okay, check the schedule. You can start your projects by now also, Kishore. It's your choice. You can take the inputs from the sessions and you can start implementing them. So I think I can hand over the session to the technical trainers, or over to your trainers. And Rajesh and Shivam, we won't be able to enable your mic today. You can ask your questions in the AMA session. So now I would request all you to focus on the session, please. Thank you. Over to you, trainers.
Thank you, ma'am. Good evening, everyone. So welcome to the new week today, and we'll be talking about machine learning. So machine learning is going to be the topic of discussion for today. Yes, good evening, all. I'm getting good response from everyone. Okay, that's good. Okay, let me start this screen sharing. Then we'll be discussing more about it. What actually we are going to do today. I hope my screen is visible to all. Let me open the chat box so that I can see your chats meanwhile. Perfect. Excited to learn ML. Okay, nice to hear that. I want this energy throughout the session. Perfect. So what is going to be the flow of the session today? We'll be having a deep discussion on machine learning. We'll try to understand what exactly machine learning is, what are the different applications, and after discussion of this technical session, we will be having a hands-on session. Okay, so we'll be working on a machine learning project, and I will be sharing the codes with you all, so that you can also work on the same. But yeah, so using the same the idea, you can also create your own project. So you will be getting one idea today how actually a machine learning project will look like. Okay, so let's get started. So learning objective for today's session is going to be, we'll be discussing what is machine learning, application of machine learning workflow, what are the steps taken over here when you're going to build a machine learning project, types of machine learning, what are the different types, the categories we are going to discuss like supervised learning. Then we'll be talking about types of regression, classification, unsupervised learning, and evaluation metrics. Moving ahead, so what is machine learning? Okay, why the term, like so many people will say we are going to train the machine, right? Yeah, it is same. We are going to train the machine, but in what context? So talking about machine learning, it is a subset of AI. With the help of machine learning, we try to achieve AI. But what exactly it is? So machine learning is a branch of computer science, we can say, um, that is based on algorithms, machine learning algorithm that is again based on maths and stats that we have studied till high school. Now using those algorithms, we used to create model, and that model is get trained on the past data to predict future outcome. Now it seems little bit confusing, right? Let me break it down. So all of you have used some platform. Let's say you might have heard about some platform like Cars 24, Spinny. What all these platforms sell? Second-hand cars, right? And you can also post your car ad on that platform. Now, whenever you are going to post the ad, it is going to ask you all the car details. Car details like number of kilometer the car has been driven, um, what type of owner you are, first owner, second owner, third owner. Then it is going to ask you the car model year, the car model, fuel type. Based on that, it is going to give you a calculated price. Now, who is sitting behind the scene calculating all these things for you? So, is there any person assigned to you behind that particular application, whatever you are using, Cars 24 or Spinny? The answer is no, right? No one is sitting behind that particular app. No person is sitting behind there. So not actually bots, Ansu. So we have machine learning models, machine learning, trained machine learning models over there. So whatever the input that we are giving, all those inputs are collected together and given to the model, and model is going to analyze that inputs, the new data point that we are giving. Based on that, we will be getting the prediction or the calculated price, or we can say predicted price, right? So basically, machine learning, what we can say, a branch of computer science where we train model on the past data to predict future outcome. You will come to know more about it when we are going to see real-time examples. Moving ahead, so what exactly machine learning landscape is, right? So what we can see, like all these things come under and comes under one umbrella, computer science, right? Why we are all doing this thing for computers only and using computer only. So subset of computer science is AI, and AI is subset of, sorry, machine learning is the subset of AI. And under a machine learning, we are having different types of categories like supervised learning, unsupervised, semi-supervised reinforcement, and subset of machine learning is going to be deep learning when we are going to work with neural networks. Now, with the help of machine learning and deep learning, we try to achieve AI. That is the basic landscape. Now, how actually we are going to train a machine learning model? How the things are going to be trained? Okay, just give me a minute. How the things are going to be trained? Now, the thing is that, first of all, we have to define the problem statement, right? We'll be defining the problem statement means what? We have to understand what exactly the problem is, right? When we are going to understand the problem, we are going to collect the data regarding that same problem. We will be collecting the data. We are going to prepare the data. Collecting the data and preparing the data means what? As you know, we need data to train the model, and data should be related to the our problem statement. So we gather the data. Okay, one question is coming here again from Sivendra. This topic is already discussed. So Sivendra, topic is discussed, but we haven't discussed in depth, right? What I told you, we are going to discuss ML topic in depth today. Have patience, okay? I don't think this thing you have discussed, right? So I told you we are also going to learn hands-on also. But before moving to the project, I want to discuss the things, in very deep manner. All right. So defining the problem, understanding the problem, then we are going to collect the data and prepare the data. Preparing the data involves so many things like cleaning the data, manipulating the data, right? If we have any null values, we are going to remove the null values. Okay, all the things I got in the same para from Salman. Salman is mentioning all the things. Yeah, so preparing the data is one of the very crucial tasks when it comes to a whole machine learning workflow. Because whatever the data that you are going to give to the model, it is going to learn accordingly. And for the same, we want to give the trained data to the model. We don't want to give the unclean data. We want to give the clean data to the model. Clean data means what? The data that is not having any redundancy, that means repeated values, or null data, or we can say uh, any missing value, all these things. And if we need to create a new column, or we want to drop a column, the column that we don't need, like you can say, whenever we are going to train a model, I'm taking out one use case. Let's suppose you want to train a model to predict the person will get loan or not. Now, the data that you will get is going to be your customer data. Customer data can contain customer phone number, customer name. This thing we don't need. So we try to drop all these things. And let's suppose we don't have customer age, but we have a column called DOB, date of birth. So from DOB column, we can extract the age of the column and age of the customer, and we can create a new column. So all these things comes under the data preparation, right? And we also select the features. Feature means the columns we want. After doing all these things, we are going to give this data to the model. Now, before giving the data to the model, we need to develop a machine learning model. We have to choose what algorithm will suit our problem. If we are into regression problem, we are going to select regression algorithm. If we are into classification problem, we'll be selecting some classification algorithm. Based on those algorithms, we will be creating the model, and the data will be given to the model. Model is going to learn from the data. It is going to understand the pattern behind the data, what data wants to say, and it will train itself. After training, we are going to test the model. If the model is working well, then we are going to uh, directly ask the model to predict something new. If the model is not working well, we are going to refine the model. Refine the model means what? There will be one step called hyperparameter tuning. What does hyperparameter tuning means? Let's suppose you're using a bike. Your bike is not working well. What you will do? You will take it to the mechanic. Mechanic is going to perform some tuning in your bike, and after that your bike will start working well. That's what we try to do with the model. But here we are not going to change anything. We are going to tune some parameter. We'll be changing some values in the parameter. The model will remain same, but the values in the model parameters may change. When we are going to be when we are going to satisfy with the result the model is giving, we are going to deploy the model. We are going to deploy the model in the production, right? Deploying the model in the production means what? As I told you, example of Cars24 website, right? So they are using the model on their application. So first of all, the model was developed outside of the application. When they have trained the model, they got the fully trained model, they have implemented the model in their production. That means they have integrated in their application. After that, we can use the particular model on the go. And this is going to be a continuous process. Why we can say it is going to be a continuous process? Can anyone tell me? This particular thing is going to be a continuous process. Like again, we have to understand the problem. We have to collect and prepare data. Again, we'll be training the model. Now, taking the same example, I'm talking about the same example. Okay, I'm getting good answers over here. Refining the model to get better accuracy, to get better model. Okay, perfect. Because error. Let me tell you something over here. Okay, let me tell you something. Let me open the sketch pad, and here I want to draw something. Simple workflow. If I'm going to put all the things in the picture, first of all, we have given the data to the model, right? Right. That means we have provided the problem statement. We have gathered the data, and let's suppose that the data set that we have given to the model was like this. Okay. I'm talking about the cars data. Okay. We are predicting what? Price of the car. For example, I'm taking the price of the car. What we have? We have the kilometers. We have the type of owner you are, right? The first owner, second owner. We are having fuel type. Then we are having what? We are having, let's say, the model or the model year. So this data we have given to the model, and model has been trained on this particular data. Model has been trained on this particular data. And whenever you are going to give a new input means what? Whenever you are going to give new kilometer, new owner type, new fuel type, or you can say the model, model year and all. So this new data point to the model will be able to predict what is going to be the price of this particular car. So let's suppose this is 1 to 1 million, like some millions amount of data point you have given to the model. Model understand this particular data, it got trained, and whenever you're going to pass new data points, like new car details, model is able to predict the price, right? What could be the price? But what we can have, like, every month, every year, you will have more models in the market. Now, the model that we have trained, let's suppose the model has been trained till June 2025. Okay, June 2025. The data that we have provided, the models that are available in the market. But when you talk about December 2025, when we will move to December 2025, what will happen in December 2025? New models can arrive in the market, right? New car models will come. Now the thing is that if someone wants to sell this new car model, our model is not going to answer this question properly, because model don't know about this particular car. We have to tell the model, okay, take this new data, train yourself on this new data. Now, not only new models, sometimes we also have some features also. Now, if you talk about fuel feature, let me tell you the fuel feature. If I'm going to talk about the year 2015, in 2015, how many of you have heard about EV cars? 10 years ago. Was EV cars there in the market? No, right? But in 2015 also, these platforms were providing you the predictions, car price predictions. 2016 also, 2018 also. Okay, only battery rickshaw were there. Yes, exactly. That we call tuk tuk somewhere. Somewhere it is called Hawa Hawai, right? Uh, yeah. So EV were not there. Yes, Sakshi Toto. EV were not there, right? CNG car were also less. If you talk about CNG car in 2015, CNG car were also less. Very few people were using CNG cars. But if you talk about these two, industry has grown very exponentially, right? Now the problem was in 2015, the model was not having the idea about, the knowledge about what is EV, what is CNG and all. But in June 2025, till now, we have trained the model till the new data set, the new data points, whatever the cars are there in the market. So the updated data set we have given. Yeah, in USA it were there. I'm talking about Indian market, right? Yes, Vijay. Yeah, in USA, people were using EV cars and CNG cars, but in India, like this is a new trend, you can say, that came 2 to 3 years ago. 3 years ago, people started using more EV, and now you will see a lot of EV cars on the road. Now, what you can see, there is some change in the data. Previously, we were having only petrol, diesel, and what CNG. Now, what we are having EV. New data point. Now let's suppose you are using the old model, and even you're going to give this particular fuel type EV to the model will not be able to give the right prediction, because model don't know the value of EV cars, right? So EV cars are having quite high value, right, as compared to petrol, diesel, and like if you talk about the similar type of model, if they're using. So that's why it is going to be a iterative process. Iterative process, why I'm want to say the iterative process. So first of all, what we are having the problem definition, right? Problem definition. Then we are going to collect the data, or we can say data collection. Then what we are going to discuss, we will be having data preparation. Data preparation. Then, like there is one more thing here I want to add. You are also going to perform EDA. EDA means what? Visualizing the data using some statistical method and all. Like till here, our data is clean. Then we will be moving towards the ML training part, right? Our model is going to get trained. Then we are going to uh, evaluate the model. Model evaluation will come over here. And the final phase is going to be model deployment. Model deployment. If I'm going to connect all the dots, now what you can see, it is just going on and on, right? On and on. It is a repeated cycle. Yes, Pranjul, you are right. I'm just putting all the things over here in short, okay? You are right. Feature engineering steps are also over here included in this step. Okay, I hope model testing is nothing but model evaluation. Okay, now let's suppose your model is trained enough, right? You have trained the model, you have evaluated the model is working fine. If the model is working fine, then you are going to choose the model deployment part. If the model is not working fine, you will come back to the training. That means you are going to train the model again by changing some parameters. Again, the model will be evaluated, then it will get deployed. And it is going to be a iterative process. Yeah, exploratory data analysis I have mentioned over here, EDA. In today's project, we are going to see few of them. Okay. I hope it is clear till now. Perfect. Now, if you talk about real-time case studies, like where exactly we are using machine learning, we are using machine learning everywhere. Whatever the domain you are going to tell the name, I'll tell you how exactly machine learning is getting used. Here we are having few examples. Crop recommendations, right? Now recommending the crop, now based on the soil texture or the nutrition the soil is having, the humidity the soil is having, whatever the nutritional factor or uh, other environmental factor the soil is having, based on that, what actually a farmer is doing nowadays, they are trying to find what crops can be grown in that particular situation, whatever the condition of the soil is. Then COVID-19. Now we all have passed through this phase, right? Now that time also AI was getting used in like predicting how many cases can arise next month, when we are going to like have the vaccination all over India. So the predictions, if you talk about, it was getting done by machine learning only, right? Whatever the things you were seeing on, like watching on the news, that as per the predicted prediction, 2 million people will get affected by COVID, 3 million people will get affected by COVID. So these prediction were made by different news channels. So they were collecting the data and they were taking the help of um machine learning only. And yeah, sales forecasting. Most of the companies who are into sales, they used to forecast the sales. Why they used to forecast the sales? So basically everyone wants to like maximize the profit and minimize the loss. If I'm going to talk about one company, let's take one simple company, ice cream company. Okay, all of you know about ice cream company. Now here they also forecast their sales. Why they need to forecast their sales? The thing is that if you see the consumption of ice cream, it will be less in winter months, like January, February, November and December. These 4 months will having very less sales. And the mid if you talk about May, June, July, these months are going to have very high sales. Why? There is a factor called temperature over there, right? Seasons also, you can say. Yeah, seasonal factor is there, right? Devasis has mentioned. Now, the thing is that let's suppose I have produced 1000 units of ice cream. but the sale is going to be about only 200, then 800 is going to get waste. Ice creams comes with expiry date, right? Yeah, we don't see, but ice cream comes with expiry date. uh, so companies can't sell expiry product. So in that case, they will be into loss, right? So that's why they try to forecast the sale. Based on that, they initiate the production, right? They increase or decrease the production, because if in summer months, if they are going to increase the production, they will get more profit. If they are going to decrease the production in winter months, they are going to decrease the loss, you can say minimize the loss. And yeah, fraud detection. Nowadays our transaction is also getting monitored. What type of transaction we are making, if you are going to make any other transaction, like you are following all the pattern. If you're going to make any transaction at different location, some unusual amount, then you may get some message from your bank, or you may also get call. It happened to me. I'm having one account in SBI. I went to Tamil Nadu, and I did a payment late night to a cab driver uh, on its personal phone pay. I scanning a QR code. Right, that time only, in the night, only in the middle of the night, I got call from, like, it was a system generated call, verifying my transaction is true or not. So these things has been implemented for our benefit only. All right, moving ahead, I hope all these things are clear. Okay, that's why Noor is saying, that's why her father's always told her not to transact at night. Okay. Yeah, sometime, not sometime, we should always listen to our parents. Now, talking about types of machine learning. So, majorly, machine learning we are categorizing into three categories: supervised learning, unsupervised learning, and reinforcement learning. So, guys, in our session, we will be talking about supervised and unsupervised. We are not going to talk about reinforcement, but I will be giving you a overview what exactly reinforcement learning is. We will be doing project on supervised. We will be doing project on unsupervised. All right. What exactly supervised learning is? Now, when we are going to have label data means what? We are having something to predict. The example that I have given you, cars data, like we are predicting price. That means we are having a label over there. Label means what? We have some target feature, a column that is going to work as a target feature. So it is going to be a branch of AI where we train the model to make predictions or decisions based on the labeled training data. Right, now here in this picture, what you can see, we are having some vegetables, and we are having labels of vegetables, right? So let's suppose this label data is nothing but the pattern that we are going to give to the model, and this is nothing but the labels. Okay, this pattern calls carrot, this pattern calls tomato, this pattern called bell pepper. Now the thing is that, let me tell you, machine learning or AI is just like a baby. If you are going to teach uh, this tomato, this is not tomato, this is apple, it will say this is apple. So that's why we have to train the model with very clean data, and no labels should be also uh, clear. So we are giving the label data and the labels. Model is going to understand the pattern. If it is round and red in color and having some green leaves over there, then this tomato. If it is cone shaped, having some leaves orange in color, it is going to be carrot. And this unusual pattern, this is going to be a bell pepper. So model is going to understand this pattern with the labels, with the name of the labels. And whenever you are going to give the test data, new data points, that is new data points, model will be able to predict what this pattern is all about. This is carrot, this is bell pepper, this is tomato. So this is supervised learning. Moving ahead, talking about unsupervised learning. In unsupervised learning, here we are not going to have any labeled data. We will be having unlabeled data. Unlabeled data means what? Here we just have the patterns, we are not having the name of the patterns. Then what model is going to do? Here model is going to use some techniques. We also call that technique called clustering. Here model will try to create clusters. Clusters are nothing but the group of data, group of similar data. Now here we have passed this particular patterns to the model. Model is going to interpret these patterns. Algorithm, that whatever the algorithm we are going to use, based on the algorithm it is going to uh, put this data points into different groups, that is called different cluster. Now best example, you can take it from your class itself. What we exactly try to do in clustering, we try to create a group of data that is having similar pattern or similar characteristics. Now can you tell me how many members are there in your class? In your college, how many members are there in your class? Let's start with our college. 60. Leeladhar is saying 60. Okay, I'm taking this number 60. Now, out of this 60, what you're going to find, there are 10 to 12 different groups of friends. Now, out of this 60, why there are 10 to 12 different groups of friends? Why there is not only one, only two? Now, the thing is that how we create our friend circle. So, like-minded people will attract each other. They start sitting together and they become friends. That means they used to perform, they used to create their own cluster. Cluster means nothing but group. That is how clustering works. So here it will try to understand the pattern, the similarity between the data points, like we used to find the similarity between our friends, right? Whatever the friends you have, now you will see you both of you are having so many similarity. Not similar in face, but similar in behavior, similar in thinking, similar in the you can say the thought process and all, right? Likes and dislikes, you are also having the same. So that is how we used to make friends. I hope clustering is clear to you. And talking about real-time example of clustering, so basically clustering is getting used in customer segmentation. What does customer segmentation means? Based on the behavior of our customer, we try to put the customer in different groups. If we are going to group the customer in different categories, then we can simply like recommend them similar type of products. Now let me give you one example over here. um, based on our age and gender based on our age and gender, you will see same similar type of products you are getting recommended on all the online platforms or e-commerce website, right? So basically let's suppose if you are a 20-year boy and you're a boy and your age is 20 years, so most probably you will be getting recommendation of gaming consoles, gaming laptop, some smart watches, right? All these things. But let's suppose you are a 20-year-old girl. Then what type of recommendation you will be getting? You will be getting more time recommendation about dresses, cosmetics, right? This is what it is happening in the real time. And can you tell me what type of recommendation of the product you see in your mother's phone or your father's phone when you are going to open the type of the same thing? How can we replace the label as an algorithm, sir? Okay, label, we are not going to replace the label as an algorithm. Okay, yes, jewelry, grocery, home decor, right? Exactly. You will be getting the home decor items, the recipes and all. Yes. What about your father's phone? What type of content you see, the products you see recommended on your father's phone? If you talk about the content, okay, cars, accessories, right? Health and lifestyle. Yes, this is what our fathers used to watch. BJP and Congress. Yeah, mostly if you talk about the content online, my father is also into more like the debate shows and all. Yes. Exactly. I hope unsupervised learning is clear to all. Moving ahead, reinforcement learning. Now, reinforcement learning is as simple as training a dog. How many of you are having a pet dog at home? Okay. Anusri is having a pet dog. Okay, nice. Why I'm taking the example of dog? Because I can't take example of cat because you are not going to train the cat. If you are having dog at home, you are the owner. If you are having cat at the home, cat is your owner. Now the thing is that we can train our dog, but when we are going to train the dog, we are going to include two things. What are these two things? So when our dog is obeying our command, we will be giving him some rewards. Rewards in the form of treats. We can give our dog something to eat if it is obeying our command, biscuit, pedigree, anything. If our dog is not obeying your command, what we are going to give? Penalty. Now, penalty in the form of like shouting at him, not giving him food, all these things. Now, based on the reward and penalty, dog minds will try to understand, okay, if I'm obeying my master command, I am getting reward. If I'm not obeying, I'm getting penalty. What I have to do, I have to ignore the penalty. I have to more focus on rewards, or I have to try to minimize the penalty. I have to try to maximize the rewards. That is what dog minds will try to think, and it will act and adapt in a situation where it is going to get more and more reward and less and less penalty. So action is going to dependent upon the same. So what we try to do in reinforcement learning, here we will be having one agent. Agent is going to be get provided with a environment, and inside the environment, agent is going to choose a policy. Right? There will be different policies over there. Agent is going to choose a policy. So if agent is going to choose the right policy, we will be giving a reward. If agent is going to choose wrong policy, we are going to give him penalty. Now here you can see in this picture, agent moved to this particular policy fire. Now here it got penalty, that is -50. Now when it comes to agents, whatever the agents we are creating, we will be assigning some positive numbers and negative numbers as reward and penalty. If we are going to, if the agent is going to choose wrong policy, agent is going to get penalty, that is negative numbers. If agent is going to choose right policy, agent is going to get positive numbers as the reward. Now after getting one penalty, agent will understand, okay, if I'm touching the fire, that means fire equal to bad, next time I have to avoid it. Then it will try to update the policy, it will choose the next policy. Now this is going to be again a iterative process until and unless model is going to get the optimal policy where it is going to get more and more rewards, no or less penalty. This is what reinforcement learning is. Okay, one question from Noor over here. I can see. Just a second. I am just scrolling. Can we say that supervised learning is like knowledge and unsupervised learning is experience? Just like simple example, a simple machine or bike is more experience than uh, race mechanical engineer. Okay. I didn't get your example. Let me tell you, like major difference over here, like about supervised learning and unsupervised learning. Yeah, you are partially correct. We are giving some knowledge. Knowledge also we are giving in unsupervised learning also, but the knowledge in the form of data that we are giving, it is labeled, right? In supervised learning. In unsupervised learning, we are not giving any label. We are telling the model, okay, here algorithm will be different in both of the cases. Supervised algorithms are going to be different, unsupervised algorithm is going to be different. The working principle of the algorithms is going to be totally different from each other. It is not going to be same. We'll be using different algorithm for all these three. How machine get reward and penalty? Very good. So whenever you are going to create this particular model, the agent, you are going to assign the reward or penalty in the process itself. Machine is not going to get, we will be assigning some reward and penalty. Okay, Tanvi? I hope reinforcement learning is clear to all. Can I get a quick thumbs up from everyone? Or you can say clear, or you can give me a thumbs up. Perfect, perfect. Okay, let's move ahead. Now we will be talking about more on supervised learning, and today we are going to do one project on supervised learning and only, that is going to be about regression. So in supervised learning, we are having two different things, that is regression and classification. Now, as we know, in supervised learning, we are having label data. That means we will be having label a column called target that we have to predict. But target could be different. It could contain different type of data. Let's suppose when we have to predict something that is having continuous data or some numerical value, like price of the car, price of the house, count of something. These are the continuous numerical value, right? The output is continuous. Whenever your output variable, the target variable is continuous, whenever you have to predict some number, that means you are into regression problem. What is classification then? In classification, we try to predict the district level or the category from the input data. So our output variable, the label data, is going to be categorical. Categorical means what? It is going to have some category, or you can say class. Let's say email. What type of email you are getting? It is spam or not spam? Yes or no? Right? We are having category. If we are going to build a model that is going to predict the person is going to, person is going to get the particular disease or not. If a person is having a particular disease or not, yes or no, right? So we are talking about different classes over here. When we have to predict some classes, that means we are into classification problem. Now here you are going to have discrete data. In the place of yes, you could get 1. In the place of no, you could get 0. 1 for yes, 0 for no. Yes, loan sanctions or not. Yes, exactly. Real estate is an example of regression. Okay, when it comes to predicting the house price, okay, Noor, when it comes to predict the house price, it is going to be a regression project, right? Because the price of the house, it is continuous value, a numerical data. Yes, exactly, Rutvik. Fraud detection. Fraud detection is will comes under classification. I hope you are able to differentiate between classification and regression. These two things are clear. Moving ahead, we will be having more discussion over here, like what exactly these things are. So here we are having some examples over here. Okay, in regression, what is going to be the temperature tomorrow? Now we can see all these things in our phone also, right? What is the temperature right now? What could be the temperature in the night? What could be the temperature tomorrow? Temperature is a continuous value, right? That means predicting the temperature over here, the weathers and all, it is going to be uh, regression. But what will be tomorrow? Tomorrow it will rain or not? Yes or no? Tomorrow the weather is going to cold or hot? That means here we are talking about some category. Here we are also talking about, you can see one more example is there. What will the house price like in my town? So some random amount over here, right? Then classification, are the amount will be affordable in my amount town next year? Affordable or not affordable? Affordable or expensive? Again, we're talking about classes. I hope by getting these examples, you are able to differentiate between regression and classification. So whenever you are going to get a problem, you have to understand what type of problem you are having. You are having regression problem or classification. Then only you will be able to choose the right algorithm. right machine learning algorithm, because for regression we are going to use different algorithm, for classification we will be using different algorithm. Yeah, all those algorithms will comes under one umbrella, supervised learning. All right, now when we talk about algorithms over here, we are having a lot of algorithms for each and every problem, and we use the algorithm when it okay, yes is asking about summary. What type of summary you want me to give? Yes, can you elaborate? Okay, till then we'll both model. Okay, here we are having, right, this is what we are going to discuss right now. Okay, so algorithms, as I told you previously, sir, how to train a model? Sahitya, we are going to discuss it today. We are going to see all the things step by step, how you're going to train a model. We'll be having a hands-on session today. Okay, let me complete this. I will be explaining all the things very like step by step. Okay, talking about algorithms, as I told you before, for regression, for classification, and for clustering, we'll be having different algorithms. For regression, we are having linear regression, and with the linear regression, we can also use multiple linear regression. Then we have polynomial regression, ridge, lasso. Then when we are going to change the algorithm, we are going to have support vector regression. So support vector regression comes from support vector machine. So support vector machine is getting used for both regression and classification. So but they are having different algorithms for both. Similarly, we are having decision tree regression. Then what we have in classification problem, logistic regression, naive Bayes, k nearest neighbors. In short, we also call it KNN. Decision tree. Decision tree, you can see decision tree is getting used in both of the cases. But here in classification, we are going to use decision tree classifier. In regression problem, we'll be using decision tree regressor. Both works in quite different way. Then we are having support vector machines also. So in classification, we'll be using support vector classifier, and in regression, we'll be using support vector regressor. Okay, it's on you what type of algorithm you want to use. Then we have clustering problems. When you, yes, random forest will come under bagging and boosting. Today, I will try to use random forest also, Sarath. So random forest comes under supervised learning. Okay, that can be used for both regression and classification. Now, for those who are not have heard the name of random forest, let me tell you about it. What is forest? Forest is nothing but collection of trees, right? Collection of trees. There are different trees. Now, in random forest, what type of trees we are talking about? Decision tree. So what we will be having, we can have hundreds of decision tree working together in one particular model. That is going to be decision tree regressor or decision tree classifier. We can use that we can use hundreds of decision tree all together is going to be random forest. And there are more bagging or boosting algorithm, like we have XGBoost also, that is going to use hundreds of decision tree at a time. You can change the number of trees that you're having, like you can use 10 decision tree at a time, you can use 100, you can use 200. It totally depends on you. Moving ahead, we are having clustering. And in clustering, we are having different algorithms. So first of the algorithm is k-means, mean shift, then db-scan. Db-scan is one of the strongest algorithm we can say. Then we have uh, uh, agglomerative hierarchical clustering. Then we have affinity propagation. Right, and if we talk about industry, what exactly getting used in clustering, people are mainly using k-means and db-scan based on the problem. Rest of the things are getting used very less. We will be using one of the algorithm today, that is going to be linear regression. So based on this particular linear regression, when we are going to work on unsupervised learning in the next class, Pardhu, we are going to talk about k-means. Okay, not today. K-means I will be talking about when we are going to work on unsupervised learning. Okay. I will be explaining all the algorithm. Whatever the algorithm I'm going to use, I will explain you. So in today's hands-on, the project session, we will be using linear regression. Let's try to understand what exactly linear regression is. Now, the formula or the equation that you can see on your screen, you might be knowing this formula before. Okay, if you don't know this formula, let me write down one formula over here. Are you familiar with this particular equation, that is y equal to mx plus c? Y equal to mx plus c. Exactly. All of you are getting all these things right. Line equation, equation of straight line. Very good, very good. So all of you know this. So that means all of you have paid attention in your maths in your school time. So this is coming from our school maths only, right? As I told you when we were learning about the concept of machine learning. So machine learning, whatever the algorithms we are going to use, will be based on maths and stats, mathematics and statistics that we have used in school. So here, what we are having the same formula, but in different way. Here we are having one extension, that is E. E is nothing but the error term. So here, what we have to do in linear regression, what exactly linear regression is going to do, based on the data points that we are having on the graph, linear regression will try to create a best fit line. It will try to create a best fit line that is going to touch most of the data point. A best fit line that is going to touch most of the data point. Now, through this line only, if you're going to give any new data point, model will be able to predict what is going to be the y. Based on the x, model will be predicting y. So here what we are having, based on the salary, based on the experience, we are seeing how the salary can be considered based on the experience. Now, through this regression line, we can predict if a person is going to give a new experience. So based on this line, model can predict what could be the salary. So here in linear regression, we basically try to find the relationship between dependent variable with independent variable. Dependent means what? The salary that we want to predict. Independent means what? Based on what we are trying to predict. That means as you can see, like salary is totally dependent on the experience. That means experience is the independent feature or independent variable, right? And what is this error term over here? Let's try to understand all these things in one picture. Okay, so this is what we are using over here. Let's suppose we are having a graph. Okay, now we are going to have some data points. I'm just putting some random data points, guys. Okay, Anurag, you can watch the recording later on. Okay, now here the goal of linear regression is to create a base fit line that is going to touch most of the data point. Now, this is going to be the x, this is going to be y, right? This is going to be x, this is going to be y. And this line is going to be nothing but the y hat. Y hat nothing but predicted y. Predicted y means what? The predicted label the model has predicted. So let me give you one quick overview. So we have a data, right? We have data in which we are having one label over here, let's say one target variable. And this is the previous data. We will be talking about the previous column x, and this target feature we will be considering as y. We are going to consider it as y. We are going to give it to the model. Model is going to get trained on this data, and whenever you are going to give new data point to the model, that means we are asking the model to predict new data point. Let's say new data, model will be giving you y hat as an output. this is what y hat is, the predicted y, and this is actual y, or you can say yi. Now, in the formula that is mentioned over there, in the PPT over here, sorry, we are having one more term called E. E is nothing but the error. It is getting considered as error. So what we are having, the formula that we are having above, how to find the best fit line. Raman Rajan, so whenever we are going to give the data to the model when the model is going to get the data, that means model is getting trained. Model is getting trained. And when the model will get trained, model will try to create this best fit line. Yes. So Kush, answering to your question, the Kush asked one question. The line should be always a straight line. Now the thing is that linear regression we are using for this purpose only, considering we are having a linear relationship between x and y, between independent feature and this particular dependent feature, right? There is a like linear relationship, so that is why it is going to be straight. Sometime it is not going to be straight, that time we'll be using different algorithm, not linear regression. How to predict new data point, I will be telling you how to predict the new data point. Now, as you can see, like with the help of this particular y, model will be able to predict if the x value, let's suppose you are having some x value like this, and if the x is coming over here, this is what the new data point is. So with the help of this particular line, you are going to predict what is going to be the y if a new data point is coming. So this particular point is going to be considered as y. Now here we are talking about error term also. What we are having, y equal to beta 0 plus beta 1 into x1 plus e. E is nothing but the error term. So what is error term over here? So this data point that you can see, that is matching this particular y over here. Okay, for this data point, this is the y, this is the y, and this is this particular point. The difference between this is going to be the y hat. This one is going to be the y hat. This is going to be the y actual data point, and this is going to be the y hat. Now the difference between y and y hat, the actual value and the predicted value, is going to be nothing but error. So this is what we are using it over here. Okay. Now here, what this beta 0 is like trying to say, this is nothing but this particular thing. We call it as intercept. And this is beta 1 is going to be coefficient, and we can say the slope also. With the help of this beta 1, we are trying to understand what is going to be the slope. So this is how model is going to build a straight line, a regression line that is going to touch most of the data point. This is how linear regression is going to work. Yes, exactly, Devasis. This equation is coming from statistics only. I hope linear regression is clear to all. Can we move ahead now? Perfect. Okay. So what is going to be our workflow over here? What we will try to do. So in linear regression, first of all, we will be having a training data set. Then we are going to understand what algorithm should be taken. We will be taking the input features, let's say the size of the house, and there will be some hypothesis like assumption. Based on that, what we used to do, we are going to predict the house price, right? Now the thing is that hypothesis means what? Assumption, right? Assumption, it is going to be a different price, but when you're going to do it with the machine learning algorithm, the actual data point, the actual price is going to be different. So here we try to create a best fit line of regression that you can see, that is going to touch most of the data point, and it is going to explain the variation over here, and each point basically represents each particular row. Okay. Okay, everything is a prediction or exact answer in linear regression. So in linear regression, basically it is a calculation, right? Calculation getting done by this particular formula, and that calculation we are going to call in another term predictions. So machine learning model after training, it predicts. Okay, it is not going to be the exact answer. We are not saying that you are going to get the 100% true result, 100% accurate result. The result could vary. The actual data and the predicted data could be different, or could be same. It depends how well your model has been trained. Okay, I hope it is clear. Can be how much is error factor in linear regression model, that we are going to see right now, Aryan. So here guys, I am just taking you to this particular project link. We are having one hands-on. So today we will be working on this project. I will be explaining all these things to you. I'm just going to give you this link. Okay. What you have to do, let me come over here to this particular GitHub. Okay. This GitHub repository is created by Tawfiq sir. What you can do, if you want to download this particular repository, you can click on code and you can download the zip file. You have to unzip it. And when you want to use the data set, there will be a notebook over here. You can click over here. You can go to the notebook. That is the Jupyter notebook that I will be using today. In this notebook, all the codes will be mentioned over here. And the data set that I'm going to use is going to be taken from this particular Kaggle repository. Okay, what a notebook is here. Okay, Kusal is asking. Yes, I'm sharing this GitHub link. Just a second. I'm sharing this GitHub link in the chat itself right now. Here you go. I have shared this link. Everyone, let me share it again. Okay. So as I told you, you can just come over here. You can click on download zip. This is going to be downloaded. Okay. Now, what notebook is here? One question getting asked by Kusal over here. What is notebook? Now, whenever you are going to save a Python file will be having one extension called .py. But when you are going to have IPYNB file, it means interactive Python notebook. What is interactive Python notebook? So Python notebook allows you to write code cell by cell. Okay, I will be using Anaconda today. I have already installed Anaconda. If you're not having an Anaconda Jupyter notebook in your system, what you can do, you can simply go on Google and you can just type Colab. Okay, here you can go on Colab and you can create a new notebook, or the notebook that I have said, you can upload it. Okay. So are you guys familiar with Colab? No? Okay, I'm getting yes, no, yes, no. Both of the things I'm getting over here. Okay. Most of the people are okay. Okay, okay. Now, Are you familiar with this particular Jupyter notebook? Jupyter notebook. What about Jupyter notebook? Let me give you a quick overview. Those who don't know, okay. Colab is nothing but a platform provided by Google where you can create machine learning project. You can create notebooks, right? Jupyter notebook, online Jupyter notebook, you can say. It is going to be an online environment. Whenever you're going to create a Colab notebook, a Colab file, it is going to be created in your Google Drive. For using Colab, you just need is Anaconda Navigator is sufficient bit to. So Google Colab is going to be online. But when it comes to this particular Jupyter notebook that I'm having over here, that is I'm having open over here, this is locally. You can see local. It is on local host. Okay, and this Google Colab is online. All right. Recording will be shared with you, Satyam. Recording will be shared in the group. And I have also shared this link, right? So I'm sharing it again. Those who have missed the link, you can click on this link, you will land on this page. So you can do this particular project anywhere. If you have a Jupyter notebook installed, it is fine. Those who are not having Jupyter notebook, they can do the same project on Colab. Now, if you want to do it on Colab, what you can do, I will be telling you the step. Okay. Let's do the same thing on Colab. Yes, recording will be shared in the group. You can also do in VS Code, Mohammed. The thing is that in VS Code, you have to install the extension for Jupyter Notebook. Jupyter Notebook will not run directly. You have to install the extension. I hope you know how to install the extension. It opened in VS Code. Okay. By default, it will get open in VS Code. If you have extension of VS Code, directly you can run it over there. But what you need dataset also. Okay, let me talk about the dataset, how you're going to get a dataset. You have to follow this link. This is the dataset link. Everyone, please concentrate for a few seconds over here. Kaggle link. So I also recommend all of you to create one account on Kaggle. On Kaggle, you will get plenty of data sets that you can use to create your own project. So I'm having one project over here, one data set, and in this data set, I'm having this particular data set called insurance.csv. It is of 55 KB, and you will get the download option over here. You can see download option. Just click here, you will get the dataset downloaded. I'll tell you how you're going to use it on Colab. So I have downloaded this dataset. I'm having the notebook with me. What I'll do, I will come on Colab. In Colab, I'm getting this upload button. Okay, just come on Google and search Colab. You will be getting this particular option, collab.research.google.com. You have to click on upload, and I'm having this particular file downloaded in my system. So this is the file. I'm going to upload it over here, and it will get opened over here in Colab. Okay. Now, if you want to, use the data set here in the Colab, what you can do, you can use two ways. First of all, you can, if you want, you can upload a data set on Google Drive. You can upload it over there, and you can connect this thing over here. So you can see there is a file option. You can connect your Colab with your Google Drive. So there is an option. I'm not having the file in Google Drive. What I can do, I can click over here in upload to session storage, and I will be uploading this file over here. Okay. Right. Is it clear to all? In Jupyter also, I'm telling in Jupyter also, those who have not installed Colab, sorry, those who have not installed Jupyter, notebook or Anaconda Navigator, for you, Collab is going to be the best option. Okay, few people are asking me to repeat. So what you can do, I think you are clear about where you are going to download the dataset from, right? This is the link that has been given there in this particular repository. So you have to come over here, and to open Collab, you have to just search Collab. Let's say Collab Google or Google Collab, whatever you want, you can just search over there and you will get this option. You have to just click here, Collab Google. That is what I have searched. You can also search Google Collab. Here you go. And I'm getting the same thing over here. And these are the files that I have already used over here in my Collab. If you want to use the previous file, you can just click on that file and you will be able to use that file. Or else, if you want to upload it, you can click on upload button. You can upload it over here. When you're going to upload it, it will open in new particular tab like this. Then what is going to be your next step? You have to upload the data here in this session storage. But you can also upload the data in your drive and you can connect the drive from here. Okay. These are the very easy step. All of you are, like technical students. I hope this is not going to be hard for you. This is nothing but an online platform. You will use it. You will come to know how to, use all the things step by step. Let me complete this, collab part. I have already repeated Kausal. If I'm going to repeat again and again, so we have having limited time. We have to also complete this particular thing. So here I'm having insurance CSV that I have downloaded from there. Send link again. Okay. I have sent the link again. Okay. Pradhu. Now we have to use this particular data set. Everyone, please look at the screen. Okay. When you want to use this particular data set, what you have to do, you have to click on this three dot. Here you will find copy path option. And in this notebook, you will find this option over here. Okay. pd.read CSV. Here you are going to just paste the path. I'm going to load this and you will see the data set has been loaded successfully. Here you go. Is it clear, guys? Easy, right? Recordings will be provided to you, everyone. Don't worry. You will get the recording. Instead, we could do in Kaggle. Yes, Hari, you can do in Kaggle. But people are getting confused over here in Easy Thing Collab. That's why I'm not showing the things on Kaggle. Yeah, Hari is right. You can create the same notebook on Kaggle also. Okay, so this is how you can work on Google Collab. Let me tell you how you're going to work on Jupyter Notebook. So those who have not downloaded Anaconda, what you have to do, you have to just search on Google, download Anaconda Navigator. Download Anaconda Navigator. So go to the first link and you will get download now option. Okay. I am sharing this thing. When you are going to download, it is going to be a huge package, guys. It needs some patience to download. Okay, after three dot, you will get copy path option. In which language we have to make our project? Python. You have to make your project in Python. You can also use R if you know. I'm just you can use VS Code, Durgam, no problem. You can use VS Code. For Excel file, also we have to use CSV. No, if you are using Excel file, then the function is going to be read_Excel. Okay, you can download it from here. Then what you're going to do, you have to just complete all the download process, then you are going to just come over here in the search bar and you have to search for Jupyter Notebook. When you are going to open Jupyter Notebook, it will get open in your default browser, or for the first time it will ask you which browser you want to set as default. So you are going to use any of your browser. You can use Chrome, you can use Edge. For me, default browser is Edge. Okay, I feel Edge is good for me, so that's why I'm using this particular browser. If you feel Chrome is good for you, you can go with the Chrome. Then whenever you are going to download the file, it will come in download folder. Now you have to locate where your file is. If it is downloaded somewhere, then it is going to be in download folder. By default, this particular option you will get. You will get desktop. You can save the files on desktop in any folder. You can save the things in download. Or else, if you don't want to save it anywhere, just select any folder and you can upload it also. There is upload option also. You can bring the files from anywhere from the upload option. Now for me, all the files are in download folder. In download folder, I am having this file that we are using right now with the name Python scikit-learn regression.ipynb. IPYNB stands for Interactive Python Notebook. Okay. How does a notebook look like? Same. The collab file that you have used, it will look like same. But one thing is different. Whenever you are going to, use the data, you have to paste the path. If you are having both of the notebook and the file on the same location, for me, the notebook and the file I am having in the download folder, then I have to just mention the file name. I have to just mention the file name. Okay. What is the file name I'm having? Let me see. In collab, we have taken, right? Insurance CSV, right? I have to use insurance CSV. I have to change the name. So let me run the cell. And for running the cell, you can use two things. Control plus enter to run the current cell, and shift plus enter to run the current cell and go to next cell. Here I'm changing the name of the file. I'm having insurance.csv. This file I'm having, and I will be importing this file. Here you go. I hope it is clear to all. Can we start working with the problem? You will get the recording, no problem. Don't worry about the recording, guys. After the session, after some time, you have to wait for some time, you will be getting the recordings. Let's get started with our today's project. Okay. Can I get some thumbs up? I need some boost over here, right? Your thumbs up, is going to boost my energy. I am speaking from the last 1.5 hours. I need some more boost. All right. Perfect. Perfect. Okay. First of all, let's try to understand what our problem is. Okay. So right now we are going to solve a problem. What is the problem? We are having an insurance data, right? An insurance company data. So in which we are having age of the customer, gender of the customer, BMI, children, like the number of children they are having, smoker, they are smoker or not, the region, in which region they live, and the charges. So these are their annual charges, basically, that they're spending on medicals, right? These are the medical expenditures. What exactly the question is? So ACME Insurance Inc., the company name, offers affordable health insurance to thousands of customers all over United States. So as the lead data scientist, so we are going to be in the shoes of data scientist, right? So we have to think like a data scientist. As the lead data scientist at ACME, let's suppose you are a data scientist at this particular company. Your task is with creating an automated system to estimate the annual medical expenditure for new customer. So whatever the data that we are going to have is going to be for old customer. Now, whenever, oh, no, this is not classification. What we are going to predict, we are going to predict this charges. Now the charges that you can see, it is nothing but continuous data, right? So we are going to predict a continuous value over here. So we will be giving this data to the model. Model is going to understand the data. It is going to learn from the data. And whenever we are going to give this new features like age, gender, BMI, children, smoker, region and all, model will be able to predict what the charges will be there for the new customer, right? We have to estimate the charges for them, like what is going to be their particular medical expenditure annually. I hope you understand the problem. Let's get started. Sir, how did you understand that it is a continuous data? Just look at the data. 16,884, 1,725, 4,449. Now, this is not discrete data, right? If the data is not discrete and you are having all these things in decimals over here, that means you are having continuous data, right? Continuous data means what? Numerical data. That is not discrete. Yes, exactly. Okay, I'm getting some. Could you give example of discrete data? Yeah, in classification, let's suppose in disease prediction, the person is having disease or not, yes or no. Yes or no could be replaced by 1 or 0. Whenever you're going to see yes or no, 1 or 0, some categories in the target feature or the label feature, that means you are having discrete data or you are having classification problem. Now, based on the target feature, the feature that we are going to predict, we have to understand what problem we are having. Right now, our target feature, that is charges, that we have to predict. If a new customer data we will be getting like age, gender, BMI, number of children, smoker and reason, we have to predict what charges they can have annually. What could be their annual medical expenditure, right? All right. Let's move ahead. One more question from my side. Do you have basic knowledge of Python? Basic knowledge of Python, not advanced knowledge. I'm talking about basic knowledge. Okay, so I'm getting yes from everyone, and few people are saying no. Those people who are saying no, do you have knowledge about C, C++? Okay, I have knowledge of C++. Very good. That is enough for me. Python is not that much tough. Java, if you know Java, Python is just going to be, butter for you. Right? Okay, the basic knowledge is enough, or any programming language that is more than enough. Okay, let's try to understand line by line. So first of all, we are going to import two libraries in Python. Okay, libraries are nothing but collection of modules that will help for doing some specific task. So pandas is a library that is getting used for creating data frames and to work with some structured data. Structured data could be CSV file, it could be Excel file. So here we are importing pandas as PD. As PD means what? As is nothing but we are using this keyword and we are giving it an alias. Alias means what? A nickname. Whenever I want to use pandas, I am not going to type PNDS. I'm just going to type PD. That's it. Right? Okay, just a second, tab got clicked. So pandas as PD. Pandas also stands for panel data. We are using NumPy. NumPy stands for numerical Python. So for doing some calculation and all, alias. Yes, Tanvi, alias. Alias is nothing but the nickname. We are importing NumPy as NP, right? And to run the cell, we will be using Shift plus Enter. When we are going to use Shift plus Enter, it will run the current cell and will take the cursor to the next cell. Here you go. Now here using pandas PD, we are going to use one of the method called read underscore CSV. As we are having a CSV file, so we are using read underscore CSV function. Control plus enter is going to run the current cell only. It will not take the cursor to the next cell. Adil. No, no, don't do side by side. Just try to see all the things. You can do the same thing after the class. Okay. Try to focus here. Okay. Don't need to do all the things side by side. If you can do, you can do. I'm not, forcing anyone. What I'm recommending, focus here right now. You will be getting all the things, all the codes and all. I have already given you the GitHub repo link, right? Sir, all these things can be do in VS Code. Yes, you can do in VS Code. You have to install the extension for the Jupyter Notebook. You can go to extension section. You can search for uh, like Jupyter Notebook over there. Okay, read CSV will help us to read the CSV file, and it is going to, the result will get stored to this variable, or you can say object. This is going to be nothing but a data frame, medical DF. And when we see the medical DF, it is having this particular data set. And in this data set, what we have 1338 rows and 7 columns. That means we are having data of 1300 plus customers, and we are having 7 features of them. Features means nothing but column. Moving ahead, now whenever you are going to work with data, you have to go through the information, like what particular column is having, if your column is having null values or not. So dot info method is going to tell you uh, like how many rows you are having in the column. If you are having all the rows, it is going to be equal to this number of entries. If you are having any null values, this number of count will be less. So there is no null values. And the third one is going to show you the data type. So data type is integer, float, and object. Integer means what? Real number, 1 2 3 4 5. Float is nothing but decimal numbers, 1.2 4.8, like that. Object means nothing but the string data, sequence of character. Like in sex, we are having male and female. It is having strings, right? Moving ahead, we are having one more method called describe. So describe is just going to give you statistical view of numerical feature. Now what we can see, we got the statistical view of all the numerical features. So out of 7, 4 numerical features we have. We are having age, BMI, and children and charges. It is going to give you the count, number of rows you are having. Mean means what? The average, standard deviation, minimum value, the percentiles, the maximum value. All right, let's move ahead. Now, what we are going to do, we are going to work on EDA now, exploratory data analysis, and we are going to do some visualizations. So here we'll try to use few of the libraries called Plotly, Matplotlib, and Seaborn. Okay. So plotly.express we are importing as px, matplotlib we are importing, and we are also importing matplotlib as pyplot as plt, and Seaborn. Let's import all these things, and it got imported. Now we will be able to use all these things. Now if you want to see, like statistical view of a single column, you can also do it like this. So medical df, the data frame, the column name dot describe, it will give you the statistical view. Now what I want to do, I want to see the age distribution. If you want to see the age distribution, you are going to use histogram. So from plotly, we are using histogram function. We are passing the data frame, the data that we have to pass. What column we want to use, x equal to that particular column. Marginal box, n bins, so you will get to know about all these things. Let's run this particular column, and here you can see what we are getting. We are getting this particular histogram. Histogram tells us how the data has been distributed. Now age 19, age 18, we are having 69 people of age 18. We are having 68 people of age 19. We are having 29 people of age 20, right? So we are having the beans, right? Like this. It simply shows how data has been distributed. If we want to print only a particular column of the data, then how we can print it? If you want to just print a particular column, let me tell you. If you want to print a particular column, you can just simply print it like this. You don't need to mention anything. You can access it like this. Column name, okay, data frame and the column. Here you go. But you can't see the entire data. You will see only few data points. N bins is nothing but n bins is number of beans. That means we are trying to say in one bin we are going to take like total number of beans. If you are going to count these beans means what? These bars over here. All these are going to be total 47 beans. That means we are taking 47 intervals over here, right? N bin is not a variable, it is attribute. If you want, you can also go by default. You don't need to mention this thing. You can go with by default also. Okay. Moving ahead, we are also going to see BMI. And if you don't know what BMI is, BMI stands for body mass index. And these are the, numbers over here. If you talk about what could be the, right BMI for us. So less than 18.5 is underweight. If your BMI is 18.5 to 24.9, your normal weight. If you're more than that, you're overweight. If your BMI is above 30, you are a obese person, obesity. If it is greater than 40, then you know what you are, right? Super obese, we can say. Now here, what we want to see, the BMI, the distribution of BMI also. Tanmay Bhatt. Okay, nice example. So I want to see histogram of BMI also. How bodybuilders will be obese. Okay, that is another. BMI basically this particular tells like according to our height what is our weight is good or not. BMI basically tells us uh, whether we should increase our weight or decrease our weight, or we are having normal weight. So you can use BMI calculator. There are a lot of BMI calculator online. Just go on Google and search for BMI calculator. I hope you know your age, your weight. Let's say I'm going to put my age. If I'm going to put my height, let's say like random thing, I'm going to put okay centimeter. It is asking 172. Weight is 84. Overweight. I am overweight. Okay. I am overweight. I need to reduce my weight. I have to go under 40, 74 kg. Okay. I hope it is clear what BMI is. So there is, like you can also create your own BMI calculator. Okay, let's see the histogram, the distribution of the data over here. Now what we can see, now there are two things guys. Whenever you're going to visualize the data, here what we can see a bell type curve. That means this particular feature is following a normal distribution, right? And here the bell shape curve was not there. Data was not following the normal distribution. Skewed data we had. Okay, moving ahead, we can also use hist plot. Hist plot is used to plot update layout. Okay, what is update layout? So update layout. So basically whatever the layout we are having, we are mentioning the bar gap 0.0.5, and you can see there is a gap between the bars. Can you see the bars that you are having? That is the gap. So this specifies the bar gaps. If you're not going to use it, the bars will be completely packed with each other. All right. We can also plot a histogram using SNS Seaborn library. We are using this particular column. medical, sorry, we are using the data set medical DF, and we are using charges, and we are going to see the charges based on the smoker. Okay, let's run this. Here you go. Now what you can see the change in the color. This particular orange means no, these are not smokers. So the number of non-smokers are less when it comes to the medical charges. And whenever you're going to see blue, so the person who are smokers, their medical charges are also high. You can see over here. So this is what we are trying to understand. Then we are also going to see the charges over here, like with the same thing. We are going to visualize with the plotly. So here we have used histogram, and here we have used plotly. The same thing. The annual charges, color we have given the smoker. Based on the smoker, the color is getting changed, right? So red is for non-smokers, right? For the non-smoker, annual charges is less. Yeah, we should not do smoking. Yes, exactly. You should not do smoking. Okay, let's have a histogram of a smoker as respect to the age, right? Color we are giving the sex, that is the, sorry, not age, their gender. And here we go. So what we can see, uh, the people who are smokers, the count of female is 115 and count of male is 159. That means male smokers are high. In none, in no, that means in no we are having the half of the particular thing, like these are the non-smokers. Okay, almost same numbers. Perfect, let's move ahead. Now we are going to use a scatter plot. So why we use a scatter plot? First of all, we have used histogram. Histogram basically we use to see the distribution in a particular column, in a single column. Here we are using scatter plot. So scatter plot basically we use to see the relationship between two variables. We will be having a x feature and y feature, right? So whenever we are going to plot a graph, we will be having x axis and y axis, right? So here we are passing the data frame. We are using the function scatter. It is going to do a scatter plot. On x-axis, we are keeping age. On y-axis, we are keeping charges. So what we want to see, if age is growing, is the charges growing, right? If like, is there any relationship between age and charges? And we are also giving the color smoker, right? Based on the smoker, the color will be change of this particular bubbles over there. The title we are giving age versus charges. Let's see. Here you go. So what we can see over here, if you see the legend, blue represents yes. Uh, this red represents no. For all the non-smokers, the charges is less. You can see we are having a positive growth when the age is growing, and we can see it is also growing upwards, right? That means as per the age, our medical expenses is going high. But when it comes to smokers, it is high from the age 18 only, right? You can see smokers are spending $36,000, $38,000 from the age 18 only. That is quite high, right? Okay, now let's see. Based on the BMI, is there any relationship between BMI and charges with respect to smokers? Let's see. Okay, so what we can see, there is no proper relationship over here. So we can't establish a proper relationship. But when you come here to the smoker, in smoker you can see it is going up. For the smoker, it is going up. That means there is a relationship between smokers and the charges. In the BMI, if the BMI is higher, if the and they're a smoker, their medical charges will be high. If they are non-smoker, even their BMI is high, their charges are less as compared to the smokers. And guys, whatever you are going to plot, you have to do in this way. You can see, I have written down the findings, what I have understood from the visualization. You have to do the same. You have to write down your findings, what you understand from this particular graph. I hope you are getting these things. Okay, let's move ahead. Let's talk about correlation. Correlation is what? The relationship between different variables. So here, what we are having charges, and we want to see the correlation with the age. We want to see the charges and correlation with the age. If you want to see the exact number, what the number says, you will come over here, you will see 0.29. That means there is 29%, or you can say around 30%, there is a correlation between uh, charge and the age. Let's see the charge and the BMI. So only 19%, right? It is less, 20% you can say. Let's move ahead. What we are going to see, we are going to create a relationship between smoker and non-smoker based on the charges. We want to see the correlation over here. So what you can see, if the person is a smoker, okay, we have said one thing, guys. We are having one dictionary, no and yes, and in the map function we have passed this dictionary, so only yes will be taken, that is having value 1. If the people are a smoker, if we are having smokers, only one has been taken over here. For smoker, it is 78% correlated. That means there is a high relation between smoking and the annual medical charges, right? So if we talk about correlation, we can directly understand the correlation from this particular graph. If you are having a upward trend, that means you are having a perfect positive correlation. But if you are having some scattering and but upward trend, that means you are having strong positive correlation. But if your data points are scattered a lot, that means you are having a positive correlation with respect to y, with respect to x, y is growing, but it is going to be weak correlation. But whenever you are going to see scatter plot between two data, two different columns, two different features, and if you are having all the things scattered over here, what you will see, there is no correlation. Nothing with respect to x, nothing is going to be done on y. Then we have negative correlation. Now, similarly, like positive correlation, we have perfect negative if all the things are aligned. We have a strong negative correlation and we have weak negative correlation. You can also take one example, as I told you before. If let's suppose we are having data of ice cream sales, right? What you will see, as the temperature is growing, ice cream sale will also grow, and when the temperature is decreasing, ice cream sale will also decrease. That means they are having positive correlation. But when you're going to compare sweater cells with the temperature, when the temperature is growing, sweater cell will drop, right? So this is how we can understand different type of correlation. All right, let's move ahead. Now what we are going to do, we'll try to use model, and we'll try to train the model. We'll try to train the model on one particular data point, right? Giving one column. So linear regression using single feature. That is also when you are going to use single feature and you are going to create linear regression, you are going to train linear regression algorithm. That means you are using simple linear regression. So what we will be using, we are going to use non-smoker data set. We are filtering out the non-smoker over here. So medical df dot smoker equal to no. All the non-smoker we have taken over here. So we got the data of non-smoker. So out of the particular 1300 feature, we are having 1064 data points, the records of non-smokers. Here we are also going to see the scatter plot of age versus charges for non-smokers. We can see there is a little growth over here according to the age in non-smoker also. Moving ahead, let's come and let's see the model. Just a second. Yeah. So what we are doing, like as you can see, like before we have already seen the formula. So it was y equal to mx plus c, right? So that's what we are trying to do. We are using estimate charges. We will be taking age, w and b, and here we are going to return the same. W, that is, you can say m x. M is nothing but the slope, age, and the b, that is nothing but the c over there, the intercept. Okay, not like this. I will be telling you how we are going to do the same. Like we are just calculating the things manually. Okay, so these are the things that we have calculated manually. Here you go. So what we have done over here, we have taken non-smokers age over here, and we have passed age of non-smokers over here, and we have given W and B over here. So what we have assigned, 50 and 100. So according to that, this is what the plot we have got. And scatter plot we can see over here. For the non-smoker, we can also see the age and estimated charges. Okay, like this. So red point, this red line indicates the predictions. Let me just take you to the final part over there. Okay, I will come back to this thing. Let me take you to the final part. Now here, what we are going to do, we are going to use linear regression algorithm. How we are going to use linear regression? From scikit-learn, we are going to import linear model. Yes, you can do similar projects in this internship taking data from Kaggle. As I told you before only, you can take dataset from Kaggle. From linear model, we are going to import linear regression. That is going to be our algorithm, right? We are going to create a model out of it. Model will be created. Now this model needs something to be trained. What we are passing over here right now, we are passing age only as input data. We are creating a simple linear regression algorithm, and we are passing the target. Target means what? The charges. The charges. So in input, we will be having like independent data, we will be having the age. Based on the age, we want to predict the charges. Here you go. And after that, what we will be having? Model dot fit. What model dot fit means? Basically, model dot fit means learn from this data. We are asking the model to fit yourself in this particular data. Yes, you can do the project like this. You can do with linear regression, no problem. You can do with any other algorithm also. So here we are asking the model to fit on this data, the trained data that we have given over here. So that is X and Y, input and targets. Model got trained, and here we will be asking the model to predict this new data points. Let's see. Here you can see, ignore this thing, ignore these things over here. This is nothing but the warning. For 23-year-old, this is going to be the expense. For 50-year-old people, this is going to be the expense, and 60-year-old, this is going to be the expense. So this is what the model has predicted, right? Let's do a few more things. So here we are going to have inputs, right? This is the input. We will be passing the whole input to the model that we have trained. And if you want to see how well your model has learned, you are going to use some of the functions that we also call as metrics. Let me take you over there to the metrics. So there are different loss function and cost functions over here in regression. So one of the loss function is root mean squared error. Mean squared means error means what? Mean means nothing but the average. We are taking the predicted data. We are going to see the difference with the actual data, and we are going to square it, and we are going to divide it by n. N is nothing but the number of data points, the number of rows you are having, and we'll be taking the root of it. Okay, so the same we are taking over here RMSE of target and prediction. Like, do I have, just a second, is not getting, okay. Okay, I have to create this particular RMSE variable that I have missed. Just a second. I haven't created. Yeah, this is the function. Here we go. So this is the root mean squared error we are getting. And you can also, like, guys, go through this file and try to understand few more things. Here, right now we have just trained the model with single feature. Now we can also train the model with multiple features. That means based on age, BMI and children, if we are going to pass these things, we are going to predict what could be the charges, the medical charges of non-smokers, right? Let's see all these things. Okay, something I have missed over here, maybe. Okay, perfect. So what I have done, I have taken age, BMI and children in inputs, and I have taken non-smokers charges here in targets. Then what I have done, I have created a model of linear regression. I have used fit inputs and targets. So we are asking the model to learn from this data. In inputs, we are passing multiple features, right? Three features, three independent features, one dependent feature. Then our model will get trained. And we'll ask our model to predict something, and we will be taking the root mean squared error that will tell us how well our model is performing, right? And now I want all of you to go through this file, and you will be having a lot of things over here. Um, just go through this file, makes your understanding. If you are having any sort of doubt, we'll be discussing in the next session. Can you show how to add CSB insurance in VS Code or Collab? In VS Code, I have already, sorry, in Collab, I have told you. In Collab, you have to upload the file over here. You are going to click on this three dot, copy the path and paste it over here. Okay, copy the path and paste it over here. It will work. If you want to use the same in VS Code, let me show you in VS Code as well. VS Code. You have to create the project. Okay. So guys, in VS Code, if you want to use notebook, let's say like I'm having one notebook over. Okay. But if you want to use the notebook in VS Code, for most of you, it is going to get automatically open in VS Code. Come to extensions. Okay, you have to come in extension, and here you have to type Jupyter. Okay, Jupyter. Search for Jupyter, and you will be getting this particular option, Jupyter. Jupyter Notebook support, right? This extension you have to install if you want to use in VS Code. All right. I hope it is clear to all. Okay, perfect. Okay, share this link in GitHub. Okay, I'll share it in. Yeah, I will share it in the Telegram group. Tomorrow also we are going to work on a project, guys. So tomorrow I will start with, not tomorrow, in the next session. Sorry. After doing this project, can we share it on LinkedIn? Yes, of course you can do. Please share it on LinkedIn. Yeah, you have to type. The code is not going to be provided to you when you're going to create your project. I will be like, I have already shared this link, right? Link to this particular GitHub repository to you, right? This particular link I have shared. So I will be sharing in Telegram group also, so that you can work with this particular project. Sir, what is your main project? So your main project, you have to decide. So your project should be on AI ML related topic. You can create any type of project, uh, regression, classification. It could be from clustering, it could be deep learning project, right? We are going to see a few more things in the next session, guys. So in the next session we are going to work on unsupervised learning also. Okay. How much time for project? So project deadline, I hope it is already given to you. I think your project deadline is Kartika ma'am. Kartika ma'am, are you there?
Yes, Piyush.
Yeah, 15th July, right?
Yes.
15th July is the last date
Yes,
of submitting the
15th July
project.
is the last date for project submission.
Okay.
Yes.
I hope it is clear to all now. It need to be done anywhere you can do your project. Front end is not required. Okay, we are not asking for front end. Theme of the project is going to be machine learning or artificial intelligence. Topic you can choose on your own. Template, yeah, we will be providing you the template. First of all, start working on the project. Today you have learned linear regression. You can create one linear regression project, right? All right. So that's all from my side. Attendance link. Okay. Ma'am will share attendance link. If you can use Vignesh, you can use as your service. It's on you.
Yes, Piyush sir. I am dropping the attendance link in the chat. Also, students, give me 15 minutes time. I will share the attendance link as well as the recording in the group because the recording has to be downloaded, has to get downloaded. Okay, so once that is done, I will be sharing today's recording as well as the attendance. Attendance link is already there in the chat here on Zoom. And again, I'll be sharing the same on the Telegram group as well. Okay. So hope you all had a fruitful session today. Thank you, Piyush sir. I hope you're done from your end, right?
Yes, ma'am.
Yes. So thank you so much, Piyush sir, and thank you so much, Rohida sir, for being there. And thank you, students. You will get the link in your Telegram group. Those who are unable to do your courses yet, please refer to the orientation recording or the guidelines PDF and start doing your courses and your project as well. Okay. So that is all from our end. Thank you so much. Your next session is on Thursday. Okay. Today is 24th. So your next session is on 26th. That is Thursday. Tomorrow we don't have any session. So you may use that time to complete your courses and you can start working on your project as well. Okay. Thank you so much. Thanks everyone.
Thank you, everyone. See you on Thursday. Bye bye.